Thank you. Thank you so much for having me. It's my first conference as feels like for ages, so I'm super happy to be back on site with people and having discussions. It's fantastic. Today we are talking about open source metrics, logs, and traces. So we had the interaction already twice. Thank you for that. Yeah, as you can see, I'm in the industry for quite a while, and then I did APM, application performance management. I think it was 1997 to no, that's not true. 2002 to 2005, and then I did other things at Hortonworks and so. And now I'm back again at observability, and a lot have changed. At the initial times, it was all proprietary software, and now we're seeing really a trend towards open source. And that's what we're talking about today. Just give you some context of where we're coming from at Grafana Labs. So we are, meanwhile, 1,000 employees worldwide. Most known for Grafana, the dashboarding site. So I would assume that probably not all of you, but many of you are using Grafana. Maybe not on a daily basis, but quite often. Just maybe you can raise your hand if you're familiar with Grafana. Yeah, I expect that it's everyone basically. I take it back, it's everyone. Yeah, but we are doing actually more. So we're helping our customers building and operating reliant, scalable, healthy systems to really provide the best service to their customers. And the Grafana logo, as I said, that's what we are mostly known at. But we do have other components like Loki for logs, Tempo for traces, and Mimir for metrics. These systems are all based on open source. But there's even more on the open source side. And again, the four major pillars on the top. But we're also still contributing and developing further Prometheus. Prometheus is also pretty well known. So if I ask you to raise your hands if you are using Prometheus, I guess that's probably the same amount of hands like with Grafana. So who's using Prometheus? Yeah. Not as many as Grafana, but still the majority. Prometheus was initially developed within SoundCloud in Berlin. That's also why we have Grafana Labs a lot of employees in the German area. But Prometheus initially was really, well, it was designed after Google's Borgmon, but it never really had in mind multi-tenancy and scalability. That's why we took Prometheus and built something more scalable, more targeted towards the enterprise, and that's Mimir. So Mimir is basically Prometheus on steroids, brings all the scalability, multi-tenancy, enterprise security on top of that. We are offering that as service in the cloud, but it's an open source project, so everyone can use it. Graphite is basically where we started on the backend side. Today I would say it's rather legacy, although you find it at some enterprises still used. We are heavily investing in open telemetry. As a matter of fact, although we have a database for storing traces, we are not investing in an instrumentation library on our own. We're rather contributing to the open telemetry world. And not only the open telemetry world, but also Jaeger and Zipkin are instrumentation libraries we really integrate with. There's also K6 I would like to mention. It's a load testing facility, also already open source, which one can find quite often used by developers. Really nice, easy setup. It's around building your tests in JavaScript. So it's really near to the heart of most of the developers. And then there's Grafana On-Call. As it says, it's a tool for managing alerts and see who's online, who needs to be informed, does something that's to get escalated, and so on. And although that's our official slide around open source, I think there was something missing, so I this morning put a slide together and added the Grafana agent, that was for whatever reason omitted on the initial slide about open source. The Grafana agent is an Apache project where we are putting together all the components you normally need if you're collecting metrics, logs, and traces. So it's Prometheus stripped of the persistence part. It's Promptail for collecting logs. It's a collector for OpenTelemetry. It's a collector for Zipkin and Jaeger. It's even an OpenTelemetry collector since last week. And as I mentioned, it's Apache open source, so just take it and use it. But we're really open in terms of what kinds of agents you're using, and that's what we call the Big Tent philosophy. So all what we are doing is based on open source, but we're also integrating with other tools customers have, whether that's Elastic or it's Slack or ServiceNow, Oracle, you name it. So the philosophy of Grafana Labs is not really to attract all the data in our databases, right, and create a kind of a vendor login. It's rather what we really want to integrate with what you have. We still think that for logs, Loki is the best, and for traces, Tempo is the best, and for metrics, Mimir is the best. But if you choose something else, you're fine, and we are integrating it within Grafana as what we call the Big Tent philosophy. And the same is true on the client side. As I mentioned, the Grafana agent is great, but we also work very nicely together with FluentBit, Logstash, Promptail, you name it. So we are really, really open when it comes to that. Because when we started as a company in 2014, we started with Grafana, obviously, but then we also created this Graphite backend database. And we initially thought, okay, that's really the best thing since sliced bread. But we pretty quickly noticed that the community really goes after Prometheus. So we very soon jumped on the Prometheus bandwagon. And then, as I mentioned, we realized, okay, there are some limitations, so we created Mimir. So Mimir for metrics is modeled after Prometheus. And then we figured out, okay, let's do something about logs. So we designed Loki, which is also modeled after how Prometheus is doing things, and we'll look into more of how Loki handles logs later on. And Tempo basically the same. So all the three major backends today from Grafana Labs are modeled after Prometheus and are really very similar to install, to operate, to work with. At the heart really is a S3 object store, S3 compatible object store, and then you have certain components for reading the data, storing the data, running your queries, and that's basically it. But one of the nice things, if you're using all the backends of Grafana Labs, is that they nicely also integrate, so you can create logs from traces, you can create measurements or metrics from logs, from traces, and so on. So it really comes together. And this will be the first demo I'll show you today, how you can monitor an application, and then by the correlation of metrics, logs, and traces, get really very quickly to a root cause if a problem arises. So let me switch gears here. Okay, that's readable. So this is a Grafana dashboard, as you recognize because you're using Grafana. And we can see that we got some alerts here. So Grafana on calls noticed me, told me, Emil, please have a look at the application. There's something wrong. And so I opened my dashboard, and I see, okay, I have concurrent web app users here. That really looks odd. 2 instances of my application instances and application server instances are running just fine, but the third one has a strange behavior. So I'm looking at the metrics here. And this is a very typical scenario, also outlined in Google's SRE notebook, that from a service perspective, you're looking at what they called 4 golden signals. We call it red dashboards, like you look at the rates of your services, the errors, the durations, stuff like that, like concurrent web app users here, or error rate below here. Do I reload? Also have a log stream here. But what I want to do is, I want to investigate what's happening with my third instance of my application instance, server instance here. So I'm drilling in. Oh, I can omit this here. So let's zoom in a little bit in the time here. Okay. Now you can notice that on top you see, let me scroll that up a bit. So the data source we picked is Prometheus. It's actually not Prometheus, it's Mimir, but in Grafana we still call it Prometheus because they are API compatible, Mimir and Prometheus, so you use PromQL and everything is the same. So we are just, to not confuse people, we still call it Prometheus. So clearly we are looking at metrics. And you see the Prometheus query language up here. So we're looking at the web HTTP requests metric. And then, which is something Prometheus brought to the monitoring, are the logs, the labels like service and Kubernetes. So that's really very similar to the Kubernetes world where we are adding labels to pods or daemon sets or what have you. That's the same in Prometheus. So now we still don't know what caused our application server instance to fail. So we are reducing that a bit. We're only interested in number 3, so we got the metrics for number 3 only. But now I understand, that something is happening, but I really don't understand what's happening. And that's normally the second step if you're correlating metrics, logs, and traces. So now you're switching over into the logs and correlating the metrics with the logs. So I'm splitting my view here, and then just go to the log side. Yep. No. Okay. Now, there are 2 things we do to correlate metrics and logs. What you're noticing is here that we're looking at the logs, and you see the log browser. And very similar to Prometheus, in Loki, you also have labels, right? And because we were splitting the views, the labels, when they are applicable to the logs, are automatically transferred to the other view, to the log view. So in this case, only the service label exists in our logs. So this is why we get the service label, but not the Kubernetes namespace. So that's not in the output of our log lines. So it's still okay. So we're looking at the log files from web app number 3. We see the number of log lines and actually the content. Now the second thing of correlation is clearly the time frame. So I want to correlate in the time. So now the time left and right is correlated. And if I drill in a little bit more, then we see that the logs on the right side are actually now adjusted. So now let me close this window here. I can scroll down, see my logs, and then I'll see, okay, there's an error happening. That's interesting. Out of memory, that's clearly an indication that, what went wrong. So the application process server just died. But maybe I want to see where in my code it actually happens. So I'm opening, that's the real content line here. And then Loki detects certain labels and detects fields. And one of these fields is the trace ID, which I can now use to correlate this log line with collected traces. So I'm switch over to the trace. Just close this window here. Now I have my trace view. So from the beginning, when the request was executed, how it runs through the application, which other microservices it's called. I can, go down. This is a pure demo application, so don't get too excited about what's written out here. It's not very interesting. But the idea really is to now analyze within my code where things started to break, and then if I identified where in my code something went wrong, then I can go back into my process and just fix my application, deploy it again, and then hopefully everything is all right. So this is how we correlating metrics, logs, and traces. And now let me get any questions so far? Okay. Yeah. And as I mentioned, all the three databases, they kind of work together, Tempo, Mimir, and Loki. One interesting dashboard I would like to show you is the following. It's very similar to the dashboard we saw before. Again, stupid demo application, showing the request rates, error messages, endpoints, latencies, response time percentiles, auto-logged errors. And the difference between this dashboard and the one before is that all what we see here within this dashboard is actually created out of traces. So there's no metrics coming from the application. There are no log files from the application monitored right now. That's purely created out of traces. So that's also a way to start with, or there's the question, how do I start with observability if I want to reduce my MTTR with applications? You can start with metrics, add logs, or you start with traces. So there are really multiple ways to get started. Honestly, although tracing is really cool and gives you a lot of insight, as we see here, it's also a way which needs to modify your application. You have to create these traces within OpenTelemetry. There are actually two ways to do that. For languages like Java, JavaScript, Node, Python, they do offer the option to auto-instrument things. So you're just adding an agent during the start of the application, and the agent figures out what needs to be instrumented and creates these traces. In many cases, the insight you get from the auto-instrumentation is good enough for what you need. Sometimes it's not, or you're having a Go or a C++ or C application, and then you need to do manual instrumentation. So you modify your code of the application, you're adding your traces, maybe adding some metrics to the trace and so on. But it's really quite a hefty impact on your application. You get tremendous insight from tracing, but it's, I would say, more an advanced topic when we're talking of observability. As you clearly understand, if you're just gathering log files, that's super simple to do. It's not intrusive, so it doesn't clash with the application. So that's a very good start as well. And then within Grafana, you can also, as I mentioned, create metrics from log files. And that's something else I would like to show you. this is an example of monitoring an Nginx server. And the only thing we are collecting here are logs. So although we see a lot of metrics, they are all created out of logs. So it's purely analyzing the log files of an web server, and you can see how, quite a good insight into Nginx you get by just analyzing a log file. So there's a lot of value if you start with logging, because it's so non-intrusive to the application, and you get a lot of value out of that. Sure. Good question. So we are creating metrics out of logs. So you can define queries like, average over time or count over time, and then the system will go through your log lines and create the averages. You're extracting potential values in the log lines. If there's error rates or durations, you can extract them, average them, percentile them, and they are then stored again as metrics. So because you don't want to do the calculation all of the time, if you open the next dashboard, you're really sending them into the Mimir database. We call that recording rules. So whenever a log line gets ingested, it's evaluated against these recording rules, and then the metrics are updated. Yeah, it depends. So in Loki, you define the retention period. So normally people are storing log lines for roughly 30 days, but we see other occurrences where they are storing them for 5 years or more. So yeah, really depends on the industry you're on, how you're regulated, and so on. Yeah, and something very new to us is front-end application observability. So far, what we discussed, these metrics, logs, and traces, they were all only collected on the server side, but not on the client, on the browser side. And that is something we announced during our conference we had in New York on the 2nd of November, ObservabilityCon, that we launched an open source project called Faro, which is about collecting metrics, logs, traces on the browser side. So that's what we discussed so far, and now we're adding the front end side of things. And of course, we will visualize the data from that in Grafana. So welcome, Grafana Faro, really new. And I played around with it and made a very trivial demo, but I think it's a nice way to get started. And this is how the things are working with Grafana, Faro. So you got your web application in the browser. It's loading some JavaScript code. You bundle the JavaScript of the agent with your own JavaScript using Webpack or whatever bundling tool you're using. And this actually will go away. So because Faro is so new, the agent itself and so is not available in the content delivery networks. That's why if you're creating something to get started with Faro today, what you basically take is your HTML code, your JavaScript code, and then you're adding the Faro Java code, have a process like Webpack running over it, and then it will create one JavaScript bundle out of Faro and your own JavaScript. Later on, if it's all distributed through the CDNs, this Webpack step goes away. But currently, if you get started, keep in mind you need to bundle the agent with your own JavaScript. I'm just saying that because that's not mentioned in the documentation. So if you get started like I did, and then you want to know, okay, how to get it to work, you will fail if you don't know that there's this bundling step needed so far. But I mentioned it will go away. So after you bundle that, then the browser with the agent clearly needs to talk to some endpoint and deliver the metrics, logs, and traces. And that's why you need the front-end application observability collector for. It's a fancy new name for the Grafana agent. So we will offer the Grafana agent as a service in the Grafana cloud, but that's in private beta right now, so it's not publicly available. So what I did, I took the Grafana agent and just throw it at Cloud Run in GCP. It doesn't have to be Cloud Run, it can be Fargate on AWS or whatever you have to, run this agent, have it, scale down to 0, but being really able to scale out. So if your application is really successful and you have thousands of users working with the application, that this part which is collecting the metrics from the application really can scale out. And then it's sending the logs and metrics to the backends, and you can visualize them with Grafana. One thing you're noticing here is we talked about metrics as well, measurements, and we are sending them to Loki. Why is that? Why is Mimir missing from this picture? And the reason is, one thing, if you are monitoring metrics, which you need to take into consideration and be careful with, is the cardinality. So all of the time series databases, they are really critical when it comes to amount of metrics, because this has a huge impact on the performance. So you really want to make sure you don't end up with too many metrics, because it will kill your time series database. So if we would send all the measurements from our browsers and still would like to be able to distinguish the browsers by IP address or username or what's in there, we would create tons and millions and hundreds of metrics, which might kill the database. Although Mimir is scaling to billions of metrics, it's just very expensive to do that. So that's not really an option. So that's why we are collecting the metrics and sending them still as log lines to Loki. And then at runtime, we are extracting the metrics per user or per device and visualize them. But we are not storing them as individual metrics in the time series database, because it would not just be, it just wouldn't be cost effective. As I mentioned, right now you run that in Cloud Run or whatever you would like to. It will be part of Grafana Cloud soon. The installation is quite easy. You do an npm install, it downloads the web SDK, and then you're adding the initialization code to your application. So this is the Grafana agent, as I mentioned, which runs in Fargate or Cloud Run. It gets an API key. That's the key you are defining, and with the API key you're allowing your application talking to the agent, and then you're just specifying some labels, and then comes this Webpack step, which is not mentioned in the documentation, and off you go. So if you like, we can do an experiment. It's a very, very simple application, just one web page where I made some experiments with HTML5 and Canvas, so it's just drawing something. And I just added some of the Faro traces and logs and so on. And we can do that quickly. So signing in. As I mentioned, don't worry about what the application is. It really doesn't matter. Just can fly around a bit. Nothing super spectacular, and that's all. But It's just one web page, some JavaScript with Pharo. And if I go to my Grafana installation here, for this demo, I'm actually using the free plan of Grafana Cloud. So it's a forever free small account you can create on grafana.com, but it really is enough to get you started. And Pharo also comes with its own dashboard. Call it front end. And we get some quite interesting insight now into the front end part of the application. So we got 5 interestingly named metrics like TTFB, FCP, CLS, LCP, and FID. Is anyone familiar with them? Yeah, exactly. I didn't knew them. They are called Web Vitals. And it's an approach from Google. What they learned, what you should monitor on the front end side of your applications. And they are a measurement of how good the application feels from an end user perspective. So I don't remember the strange names here, but it gives you insight into when was the page initially visible within the browser. When did the user started interacting with it? When were all the images loaded? So it's they are metrics which are not created by the Pharo SDK itself, but it's data which is collected by the browser, and that's important because the timer actually needs to be started before the Pharo agent actually is loaded, right? Because it's part of the being loaded itself. And it's dependent on the browser to be implemented. So Chrome implements all 5 of them already. Safari, I think only 2 of them, but we expect also Safari to collect all 5 of them in the future. And then Google also gave us hints into which values are good, or which values you should improve on. And that's also built into in the dashboard. So if it's red, it's clearly not that good. Green is okay, and yellow, you could have improvements. Then we are showing 75 percentiles of these values. We get insight into the exceptions, the URLs, errors happening in the application, the distribution on which browsers were used, and so on, visits. So this is all now coming from the client side. And we can now also correlate data we collected on the browser with metrics, logs, and traces we collected in the backend. So we want to understand the trace from a specific user, how it went from the browser through the backend to the database. So I'm looking now at Tempo, which collects the traces, not only from the backend, but now also from the application, from the browser side. So I want to start with a browser, and I'll select a span, like the load status. So you can hardly read it, but on top of left it says all green. That's the status, which is collected from the backend, from the database actually. So I want to investigate into these. And we can dive in here. See if I picked a good one. Yeah. So yeah, I picked my trace. And there's actually one bug because it's Faro is still in beta. You can see that the request started at 0 microseconds, but then the tool is claiming that it actually took 200,000 days to complete, and this is not right. Pretty sure about that. So this is something we still need to fix. So forget that for a second. But if we're looking at our trace now, we see it starts within the browser. And I have some more information here. Like the attributes. So it's coming from a Macintosh that probably was myself. It's instrumented by OTel. We see the labels and similar to this one here. But then it goes, the application talks to a Node.js microservice in the backend, and then this microservice will connect to a second one. So the browser talks to the Node server. We get insight into what's happening there. It's mostly Express middleware, so not too much of interest here. But then there's also the call from the one Node server to the persistent server. That's also a Node.js application in this case. Again, runs through the middleware. But eventually, we end up with a select statement which was executed and gets the status from the database. And to us, that's really exciting and very new, because it's the first time that we can connect the browser with metrics or SQL statements in the database. And clearly there was something which was, I think, still missing in the Grafana product portfolio, but with Faro we catched up for there. That's a good thing. Any questions around Faro?
Yeah. So Faro is only needed when I want to trace it, right? Because for log files you're shooting at something like file lead. This Faro overrides the system call, right? I understand it correctly.
Yeah, but you might have logs in the browser itself,
Okay.
right? You know, your console log output as an example.
For example, now it's out of question that we override all the system calls with some proprietary protocol you understand, Jeff.
Yeah.
We would definitely would be interested in sending the logs
Uh-huh.
alone. We have something in place for that to do that task. If I'm only interested in the logs of the application and I don't want to use Faro to override system calls, there's no way. So I have to use Faro.
No, Faro is just part of what runs in the browser.
Okay.
But do I understand you correctly? You want to collect logs on the server side? Yeah. Then you can use whatever tool you want for that. You know, whether it's Promtail, FluentBit, Logstash, whatever writes to Promtail compatible. That's works. Please.
So if I now ship telemetry to the user's browser,
Yeah.
is there any data protection considerations I would have to take into consideration?
I wouldn't say it's different from what you need to do on the server side, because even on the server side, clearly you have the IP address, you have the username.
But it just feels to me different than having that in the browser. But I might be wrong.
Maybe there are potentially more intrusive ways, but I wouldn't say it adds another dimension. I mean, there is data which needs to be protected, and you need to take care of it and treat proper, independent of where it comes from. Yeah. There was another question here, please.
Yeah, just to expand on that.
Yeah.
So you have a possibility when you get the consent that you just activate Faro, because usually even Firebase and so on have GDPR protection. So if you don't get the cookie consent,
Yeah.
So is there any initialization hooks for Pharo that you disable it unless you get consent?
As far as I know, there's nothing out of the box, but it's pure JavaScript in your application. So you have to tell Pharo to initialize, and you can clearly add a test in front of that. Did my user consent? Then do that. If not, just skip it.
And the second question will be, do you plan to extend Pharo to the native mobile application space?
Yes.
This is the missing piece.
It is, yeah. So far, it's really just JavaScript and has an integration with reactive web pages. But yeah, I mean, clearly iOS and Android are on the horizon as well. And it's open source, so you can always contribute. Yes, please.
Can you say a word about the performance implications of running this on the website? Usually web browsers are very intense, lots of operations there, and doing a trace on each operation on a web constraint, web browser constraint could be overloaded.
Yeah, that's a good point. I don't think we really have good insight into that. The tests I personally did are very promising. I was surprised how few load it actually puts on the browser. That might just be, because meanwhile the CPU we have on our devices is so powerful. But I'm still a little bit worried because JavaScript is inherently single-threaded. So if you're sending something to the backend which doesn't scale, it can have an influence and will have an influence on the overall user experience. How bad it is, I don't really have a good gut feeling because it's also so application dependent. But it's clearly something you should have under control. So it's important to test that. But at least something like the Web Vitals we were looking up front, that should not have any impact because the browser is collecting them anyway. It's just a tiny amount of data you're sending back to the backend.
Yeah, these are built-in benefits that are exposed automatically. But traces, each operation being performed in the browsers are very, very, there are lots of operations internally, and having a span emitted for each and every one of these lots of operations.
Yeah, we were not tracing the browser itself, right? It's the JavaScript code of your application which will be instrumented. And that's, if you don't do manual instrumentation, that's just limited amount. Still, it will have an impact on your application performance, right? But it's not that we are looking into the browser, what the browser is doing. Does that answer the question?
Good to know that it's on the browser operations, but again, client-heavy applications, browser-heavy applications.
Yeah.
How much performance load does it impact? But I understand there's also.
Yeah, I mean, there will be some impact. And that's a good point you're bringing up here, because one way to measure that is to test it. And as I said, K6 is an open source load testing tool from us, which you can use. And normally you're using it to testing APIs. But now while we're going into the browser, it's more important to test what's happening within the browser. And there's an extension to K6 called K6 Browser, which remote controls Chrome instances. So you can say, I want 4 or 5 instances of Chrome started, hit a certain web page, get me some information from the document object model, type something into an input field, press this button. So it's really remote controlling your browser. And then you get insight into the performance of your application within the browser. And that is something you can work together with Pharo. to measure what's the impact of Faro on your application. And it's also a good thing to combine the traditional load test, where you're just hitting, you know, your HTML, HTTP endpoints with thousands of requests, and then have at least a certain amount of Chrome instances being remote controlled with Faro enabled in your application, and watch the web vitals while you're doing your load test against your HTTP endpoints. So you get a good impression of how does my end user experience is impacted under heavy load on the application.
1 second, I'm sorry to interrupt.
Yep.
I just have a quick side note. If you have a room in this hotel, checkout is at 11 o'clock, so. Okay. Sorry.
Sure.
Is there a way to filter? Because normally I'm not interested in all the traces.
Yeah.
I'm only interested in the faulty ones. Is
Yeah.
there a way to tell Faro, this is a header, like there's an authentication string in there, and if you find that, then send everything. And if you don't find it, just send the vitals. That would be a great solution.
Of course you can do that. I mean, it's purely JavaScript, right? And you have to tell Faro what to do. And if you don't want to send something, then just don't call it in this instance. So this is the GitHub repo of Faro. And if you go to the quick start, there are some examples here how to use it. Yeah, like here, right? You know, you're pushing a lock, and if you don't want it because you think from your application side you don't want it, just don't do that, right? Good. All right. So. And then I wanted to give you quickly an insight into Loki, because it's close to my heart, and I think log analysis is so powerful and so non-intrusive to many applications that it's certainly something you should have a look at. We are currently at 2.6, and 2.7 was released, I think, Friday last week or so. So 2.7 is already there. We are still saying 2.7 on the slide, need to update that. And the most important update with Loki 2.7 is that we made a huge performance improvement. So we got 4 times faster queries, and we are using less CPU. And the reason why we were able to make such a huge performance impact, because it's a factor of 8, right? So 4 times faster queries with 50% less CPUs, is that we changed the underlying index database. So Loki is very different to many other log analytics tools, that it's not indexing the content of your log lines, it's just indexing the labels. We were switching from BoltDB to the Prometheus used indexing mechanism, and that just gave a huge performance improvement. So Loki itself is the persistent storage for your logs. It's leveraging object store, whether that's S3 or something compatible. It has a REST API, it has a command line interface, it works with the Alert Manager and Grafana, obviously. And then you have Promptail or the Grafana agent, what you like to send the log files to Loki. And as I mentioned, Loki is really modeled after Prometheus. That's the Prometheus storage model. So in Prometheus, we got the timestamp, we got a metric name, and we got some labels here. And then the value of the metric. And it's very similar in Loki. So that's the Loki storage model. We got the timestamp in nanosecond precision. We got the labels, as we did in Prometheus. and we get the content. That's just what you send to Loki, your log line. And only the labels and the timestamp, that's indexed in Loki. The content itself is not indexed. We store it as it is. And that's so powerful because in the world of logs, most of your logs are never read again. So you're storing them, but then your application is up 99.95% or whatever, and you just don't need most of the logs anyway, right? So we believe it doesn't really make a lot of sense to do the traditional way of working with logs, is where on ingest time you're indexing all the content of your logs. The indexing is CPU and RAM intensive, so you need a lot of machines to ingest your data, and then later on you will never read most of the log lines anyway. So why doing that? And we think that's just wrong, the traditional way. And also the traditional way needs you as a developer to agree on the format of your log lines, because your log lines need to fit into the index you are creating. And as a matter of fact, that never really works, because someone who is writing some log lines is new, he doesn't know about the index you're using, or he's bringing out a fix at 2 a.m. in the morning because there's a really security issue with that, and suddenly you're starting losing logs. And that's, I think, the most important feature of Loki, that it doesn't force you to certain schema or whatsoever with your logs. You're just sending plain logs. So we are open to any logs, all formats. We have very small index because we are not indexing the content itself. It's cheaper to run. It has fast queries, not as fast queries as if you're indexing the full content line, that's for sure. At the indexing part with full indexing is just faster, but it's fast enough, we say. And it's the better way to do things. It's an example here. So very typical, an index which used to be 10 terabytes is now only 200 megabytes, so really easy to handle, very cost efficient. And then if you are now querying your log files, you might have 1 petabyte of raw logs, which are not fully indexed. But then normally you're not reading all of your log lines because you're storing them for, 30 days or 6 months or whatsoever. But if you have a problem with your application, normally you're picking a day or even an hour or something like that. So you're reducing the amount of data you read from 1 petabyte to maybe 80 terabytes or whatsoever. And then we match the labels. And remember, the labels, they are indexed in Loki. So that's also fast. So from the 80 terabytes in this example, we go down 1 terabyte. And then we are reading and doing a brute force analysis on this terabyte at query time. And with Loki 2.6, we were roughly at 120 gigabytes per second. So that would result in a roughly 8-second query in this example. With 2.7, we are at roughly 400 gigabytes per second. So it will go down to 2 seconds. It's still, very likely slower than a query on a full indexed system, but you're not paying the price to index 1 petabyte of data, which is hefty. This is an example of what Loki can do. That's before 2.7. So that's a huge cluster in Grafana, but nothing extraordinary, with 700 megabyte per second ingest, which results in 43 terabytes a day. And we're running that with 170 cores and 1 terabyte of RAM. And we expect that to go down dramatically with 2.7. And on the query side, we also copied with pride from Prometheus. So the query language for Loki is called LockQL, not PromQL like for Prometheus, but it's very similar. So you start with a number of labels. So you're picking we call it stream. And then in this case, we say, okay, we want to see every line which includes a certain text, like in this case, trace ID. And then we also do want a regular expression match. So you can extract data. Also, what you can do, which is not shown here, you can format your log line. So as an example, you might have a collection of JSON and just text output in one line of your log input. So you can extract the JSON by a regular expression as an example, and then have the JSON formatted, extract some fields of JSON, and then do metric queries on that. So you can calculate, sum over time, min over time. Quite often, count over time is something which is very helpful when it comes to logs, like count over time the number of log lines which contains error as an example. Sounds very very reasonable. You can do things like sum and max, standard deviation, variable, top k, bottom k, count, and things like that. Say again, please. Correct. Yeah. So good question. So the question is, do we have recording rules on top of that? Very true. So if you have a query which makes sense to you from use case or application perspective, you can create a so-called recording rule out of that. So that will be something which is evaluated within Loki whenever data gets ingested, and it will update and calculate the results of your queries and store them as a metric. Can quickly show you that. Let me see. Oh, no. Yep. So I'll show you that because it's kind of hidden. So in Grafana, when you go to alerting and you create a new alert rule, and I think it's somehow unlucky that recording rules are hidden behind alerting, but they not necessarily have anything to do with the other. And then they have the Mimir or recording rule. Click this one. And then you picking your data source. That would be Loki then. Right. And then you're creating your Loki query here. Can potentially create alerts out of that, give it a name, add some labels, and then you're saving that. Your recording rule is all set. Yes, please. I actually don't know. As I indicated, I'm not really happy how it's done. I think it was just because Loki doesn't really have a user interface, so we didn't really had a good way of doing that. You can still, go into your YAML of Loki and add it there. So even if we are adding that on the Grafana side here, that doesn't mean that the recording rule is executed in Grafana. It's executed in Loki, right? And you can add them within the configuration, but there's no Loki user interface to doing things, and we did that Grafana. Correct. Yes, you have to provide Loki with a destination of your metrics. That might be a Prometheus or might be a Mimir. Yeah, and that's in Grafana Cloud. What I'm using here, that's pre-configured, so that will be your Mimir, which is in Grafana Cloud as well. If you run Loki on premise, you specify where the metrics should be stored. Yeah. Well, I don't know Thanos good enough, to be honest. That might be a question to the Thanos folks. But I would be surprised if Thanos can create the metrics out of logs, because it wasn't really meant for that. Okay, I think we are 1 minute over already, right? Sorry for that. But we are in the question and answers already, so I think it's good. Yeah, and that's all I had, I think. Let me quickly go back here. Yeah, just one more thing. So if you want to get started with Loki, you have multiple options. You can start it with a single binary. You can run it as microservice, use it in the Grafana cloud, and there's also the enterprise product for it. So it's in the cloud. You know, just use the free account and you get started within in minutes. And there we are. Thank you.
Yourself go and get funky. Let yourself go.